This is Algebra 2 with trig. This is a review for the quiz 7.5, 7.7. Here we're noticing that the log of 4 is approximately this value. The log of 7 is approximately that value. We're not supposed to use a calculator to just plug this in. We're supposed to show our steps. So to show our steps, we're going to say log of 4. You could say 4 times 4, or you could say 4 squared. You don't want to say 8 times 2, because we don't know what log of 8 is, we don't know what log of 2 is, but we know what the log of 4 is, so we want to use 4. Now using our properties, that means that we bring the 2 in front. Log of 4, we're told, is 0.602, so we know that this is going to become 1.204. The next one, again, we want to use 4s and 7s only. So we would write this as log of 49 minus the log of 64, because it's a fraction, so we separate them using the properties by a minus. Well, 49 can be written as 7 squared. 64 can be written as 4 cubed. Remember, we can only use 7s and 4s. So we bring the 2 in front. We bring the 3 in front. So 2 times 0.845 and 3 times 0.602. So using our calculator, we have 2 times 0.845 minus 3 times 0.602. That comes out to be negative 0.116. You got to have those steps. Don't just plug this whole thing into your calculator. Next, we're going to expand. That means we're going to write more logarithms. So first we notice that x squared and y are multiplying to each other. So that means we're going to write them with addition separating them. Then I'm going to bring the 2 out in front, and I've done everything I can. This next one, again, we have multiplication, so we're going to add for the cubed root of x. Well, log of 5 is all set, but I know that the cubed root of x can also be written to the 1/3 power. And if that's a power, then it gets put in front of its own log. Log base 6 of xy squared minus log base 6 of the square root of z. Because it's a fraction, we're going to write it with subtraction. And then because it's multiplication, we're going to write it with addition. Nothing we can do here with log base 6 of x. We can bring the 2 in front of the log base 6 of y. And I know that log base 6 of z to the half power is the same thing as the square root. So I'm going to bring that in front of its own log. Now we're going to condense. We're going to write it with a single logarithm. So I first noticed that the 3 can go up on top of the x as an exponent. then because we have addition, we're just working left to right, we have addition here, so we're going to say log of 4x cubed, so we brought those two together, minus log of x minus log of 6. So we'll take the 4x cubed and put the x underneath it. Then we'll take the 4x cubed and put the 6 down with the x. And then I can simplify. The 4/6 can be simplified to 2/3, and the x cubed x, there are 2 extra x's on top, so it's x squared. Letter B. I bring the cube up on top, bring the square up on top, now I could write this out the long way and FOIL that together. You cannot call that x cubed plus 1. You can't distribute that 3 through. But with the minus, the minus puts the y squared on bottom. The plus puts the y in front, or puts it on the same level at least with the x plus 1, and I wrote it in front. Another plus tells you to write the 2 as multiplication with those things. Now, because we have something we can reduce out of here, nothing's being held together by addition. The 2 times y and the y times the parentheses, so I can reduce the y from the top and the y's from the bottom. So this is going to become the natural log of 2x plus 1 cubed over y. For the change in base formula. Looking here, our calculator naturally can do the common log, which is base 10. So if you type in, hit the LOG button, and immediately hit 18.1, that's going to tell you how many times 10 to what power equals 18.1. We want to know how much is 4.2 to what power. So it's going to be a larger number instead of base 10. So a way to do this is to write the log twice, and this is what we would like to see on your quiz. Show that step. Show that you're putting the log on top and the log on bottom. And then we would use our calculator, and we could say log of 18.1 divided by the log of 4.2. Sure you use your parentheses correctly. This is approximate, be better terminology. 2.02. We rounded to the nearest 3 decimal spots actually. Would round that out to 1/8. Following the directions. This next one, we have log. Notice how the 0.0005, it's a bigger, physically larger number. It's smaller in terms of a value, but it's on top of this 1/3 essentially. So that goes on top of the fraction. This change of base formula is the only place where you write log on top of the fraction and on bottom of the fraction. It's the only place. Sure you have 3 zeros before the 5. So then, with our calculator, we'll type in log of 0.0005 divided by log of 1 divided by 3. You want to be sure to not just use a decimal like 0.3 or 0.33. You need to use the 1/3. And that's going to approximately be 6.919, rounded to 3 decimal points. Now to solve. To solve, we need to get the e to the x isolated. Now this is just exponential form. We're solving for an exponent. To solve for an exponent, you need to use a logarithm. We get to use natural log because the base is an e. Natural log automatically has log with a little e below it. So we just actually write ln. So using our calculator, the natural log of 6 comes out to be 1.7. This is to 3 decimal spots, 1.792. Here we would add the 12 across. Again, we're trying to solve for the exponent, so we're going to use a logarithm. It has a base of 10, so that's a common log. You can write the 10 if you wish, but you don't even have to write the 10. Using our calculator, the log of 34, change of base formula is not needed. And then we subtract 2. So I would use what your calculator actually has in it and subtract 2 from it to get our negative 0.468, and that gets rounded up, negative 0.469. This next one is a little bit different. Notice that we have exponents on both sides of the equal sign. That's a good hint to us that most likely we're going to be trying to get the bases the same. So what can make an 8 and can also make a half? 1 over 2. So if we had 2 to the 3rd power and 2 to the negative 1, remember the negative puts it into the denominator, then we can distribute and distribute. Negative 1 times negative 1 is positive 1. This would be a negative 2x, so I'm actually going to add the 2x to get 5x here. So x is actually 4/5. Solve the logarithmic equation. So here, notice how both sides of the equal sign have log base 7. So if they're both the same, the only thing that could be different would be the 2 minus x and the 5x. That's the part in question. So we'll add the x to the other side. So x equals 2 divided by 6, which is the same thing as 1/3. And we got one answer, it's a positive. We plug it in, 2 minus 1/3 and 5 times 1/3. It'll work out the same. You can go through all those details. But remember, you can't take the log of a negative number. That would require or that would force it to be an extraneous solution. So here, some people might think about putting the 2 on top of the parentheses. I would suggest just dividing by the 2. Now we have a logarithm, and the logarithm equals 6. It doesn't equal a variable, so we know what the logarithm equals. That means we know what the exponent is, because a logarithm equals the exponent. So 7 to the 6th power, because that's the exponent, 1 minus 2x. 7 to the 6th power is a really big number. 117,649, 1 minus 2x. We can subtract 1 from that to get 117,648, and then divide that by negative 2 to get negative 58824. This one here is 2 logarithms. We're on the same side of the equal sign, so it's not like what we did on the first letter A. We're on the same side of the equal sign, and that actually equals something else. Remember, when you have logs that are being added to each other, another way you can write it is condensed into 1 logarithm. So 6 squared equals 2x minus 6. Remember, the logarithm equals a number, and if it's not a variable, then we don't need the logarithm anymore. We can get rid of the logarithm by writing it in exponential form. So this is 36. This is actually going to come out to be 2x squared, minus 6x. 2x squared minus 6x. Subtract the 36 to the other side. We can factor that 2 out. You can completely forget about that 2 if you wish, just by dividing it out. But this, I like to remember it's there. Just for other problems, some people forget about it. X and x, we have what multiplies to be 18, but 6 and 3. More negatives make the adding to be negative 3 and a positive. When you add these two together, you get negative 3, but when you multiply them together, you get negative 6. So 2 doesn't equal 0. X minus 6 might equal 0. X plus 3 might equal 0. So x is going to be 6. X might be negative 3. Think about if you plugged in your negative 3. That becomes extraneous solution, because the negative 3, when you try to do 6 to what power equals negative 3, there is no power that you can give to the 6 to make it be a negative 3. So that's why that's extraneous. Our only correct answer is 6. Number 7, compound interest. So here our formula is A equals P 1 plus R over N NT. Notice that our deposit is 700. That's the P value. The P value is how much your account has in it. A is how much it's going to have in it at the end. The P is how much you're depositing, really. The A is how much your account has in it, typically at the end. The 2.75 is your interest rate. We need to write that as a decimal. So the A value here is your amount you want the account to be. So we have 1,000. If you deposit 700, and you only make 2.75, and this is getting compounded quarterly. That means there's 4 quarters in something. 4 quarters in a football game, 4 quarters in a dollar. 4 is quarterly. And then 4 times t. Unfortunately, we don't know what t is. We have to have some variable to solve for. So when we look at this, we can figure out what 1 plus 0.0275 divided by 4 is. That comes out to be 1.006875. So now, some people are going to make a mistake and they're going to multiply that value of 1.006 to the 700. But that's not really 1.006, it's to the 4th power, so we can't do that. We have to divide by 700 to both sides. And we take 1,000 and divide that by 700. We get 1.429. Now we're trying to solve for the exponent. So here we're going to write it as a logarithm. Remember, a logarithm equals the exponent. So what I'm going to do, I'm going to say log. What is my base? The base is the 1.006875. The 4t is what the logarithm equals. So the 1.429 is going to go here. Logarithm equals the 4t. Now this looks crazy. We're going to do the log of our 1.429 over the log of 1.006875. That's called the change of base formula. So I'll bring the calculator over. We want to keep this 1.429-ish type number because we want to do log of this answer. Don't plug in rounded numbers into your calculations. Divided by the log, and that's one reason why I left it at 0.006875. I didn't want to lose that full number. We get 52.058. We divide that by 4, and we're going to get 13.01 equals t. So about 13 years. How long is it going to take to double the original when the interest is compounded weekly? Well, the original was 700. Doubling it means timesing it by 2. So when are we going to get to 1,400? Well, we're going to start out with 700. Compounding it weekly, there's 52 weeks in a year. How long does it take, they asked. And that's when we solve for the t. So we have our 1,400. We'll take our calculator and do 1 plus 0.075 divided by 52. And we'll get 1.0014. We don't want to lose that number. Now we'll divide by 700. And that just comes out to be the number 2. So here we can say log of 1.0014. It's really more than that. Of 2 equals 52t. So using our calculator, we'll do the change of base formula. So we'll do log of 2 over the log of the real value of 0.0014. So the log of 2 divided by the log of our previous answer, and we get the answer of, I believe that's right. Now I'm just nervous. Was our answer really that last? I might not be correct on that. Let's hang on a second. Let's go back and get that. 1 plus our interest rate was 0.0275 divided by 52. Oh, let's take a look. What happened? This should have been, doesn't look like I hit that right, 0.275. That would have been a little bit different here as 0.5. That's why it's important to plug in the real number, not some rounded value. Be sure you plug in the right number. Okay. So now we're going to do log of 2 divided by log of this answer. And we're going to get 1,311. And when we divide that by 52, we get 25.2. So over 25 years.